Hi, today we're going to continue our discussion on deploying your machine learning model at scale. In particular, we will look at browser-based model using TensorFlow.js. Are you ready for this? Here we go. Well, first is why do we have to get our model onto the browser? Certainly, the browser can give a lot of advantages over traditional servers client model. Number one is if you run the model directly on the browser user um, user browser, then there's no need for an expensive server. And let me tell you, running a large scale server can be pretty expensive. It's also make your app or your website more reliable because it reduces the latency between communication between the user's app and the server. It's also remove the need for the query the server to make in order to make prediction. Yeah, and it would definitely make your website more responsive, and most importantly, it protect the user privacy by not sending the data to a server. So, and it work with a variety of servers, and these days most of the users are familiar with one of the kind of user of the browsers below here. So first, let's talk about what is TensorFlow.js, which is a Google-made framework to support JavaScript developer to make machine learning easy to integrate with their websites. And TensorFlow is a relatively new framework. It started in 2017, launched in 2018, so it's pretty young, and is actively developed by engineer at Google. The developers of TensorFlow.js, using TensorFlow.js, can run existing model, retrain them, or train them from scratch using traditional ML development. The TensorFlow.js contain 11 free-trained model. Most of them are for vision tasks or the natural language processing, and a bunch of tools to tune parameters, auto MLs including. So how do you code your TensorFlow.js model? Let's deep dive into it. Now, I'm going to assume you have some knowledge on JavaScript. If not, it's okay. You can kind of follow along and you're going to learn a whole lot. So number one is the first thing you have to do is include the TensorFlow.js library. Just like the include in C++ or you import in Python, you're going to have to include so we know that we're going to use some TensorFlow.js. And here the script to include the latest version of TensorFlow.js. Okay. After you give the include to TensorFlow.js, what you do is you can start building your model. And this is the script to build the simplest sequential model out there, right? So you have your model declare with a TF sequential model. And what you do is you're going to add a single dense layer with one unit and taking a number at input, right? We're going to make it very simple, right? So one unit, one layer, one scalar at input. And then you compile your model just like for your Python counterpart. You compile your model by declare what is the loss function with you, mean square error, TMSE, and the optimizer we use stochastic gradient descent. So you can declare it like a list here. Loss, colon, the value, optimizer, colon, the value. And then you can just print out the summary of your model by calling model summary. So you can see a lot of Python influence here. Somewhat adapt to JavaScript syntax, but you can see if you know Python, you can read this and understand what it does. Next is adding some training data, and this one we also make it simple. We'll add input data and then also the label, right? So the input data is declared at a 2D tensor, and it's just a bunch of numbers here. It's a 1D array, and notice that I use slightly different format here, not just input the NumPy array, right? It's no a NumPy array in JavaScript. So instead, I'll use the TensorFlow format called Tensor2D, and I input two things. Number one, I input the array of the input data, right? It's 1D array. And then the second one is the shape of that input array. So we need to know the shape information as well. We don't have a luxury of NumPy here. So the shape here, just how many element in the array, and this is a one-dimensional array, so that's 6 and 1. Basically, the shape of this input array, right? And we do the same for the label, which is another 2D tensor, and it has corresponding labels here and the shape, right? Now, if you look at the two input and you're super awesome at math, you may recognize the pattern right away, right? Many of you probably already have the relationship between input and output. But I'm going to tell you anyway, the relationship here is the output on the label is 2x minus 1, right? 2x minus 1. That's the relationship. So we want to, this neural network going to learn this relationship. Basically, you're going to learn two weights here. Number one is the bias term, which is minus 1. And the weight would be 2. All right. So we're going to use stochastic gradient descent to do this, right? So I'm going to show you a demo real quick here. How you put everything together in a simple website and web page, and see how integrated into the TensorFlow.js, right? So we'll start our website. Here we go. It's our first HTML page, and it looks super innocent. All it say is just a header saying first HTML page, but it's a little bit more than that, right? So certainly this pop up saying the number 9 here. So let's see what's going on here, right? So I'm gonna bring up the developer console. You can go it by going down to here, more tool, developer tool, right? Okay. So we look into this is, having all the element of the HTTP HTML page, and the header is here. Now though, what important here is the script that you insert, and this is what we have talked about earlier, right? So first thing you do, you insert this script to have access to TensorFlow.js, and then you have a script to start building your machine learning model, right? So I'm gonna go back to that asynchronous, meaning that you want to have this asynchronous function, so it don't take off the load of your website. Sort of done is sort of asynchronous instead of synchronous. Synchronous typically haul off your other functionalities. You want to do this asynchronous. All right, so this is do train your function, and what the do train is just called the model fit, right? And the model fit is just input in data x and label y, and you also insert another list to have specify some parameter like the epoch. In this case, I want to run 300 epoch. And then instead of having a separate callback function, you can actually implement the callback function right in the fit by having callback colons here with the list. And then on epoch n, what you want to do here is you try not to print out the epoch and the loss. So that's why you have epoch loss, and then you console to print it out, right? By the way, if you look at the console, this actually get printed out when the page was loaded, and it was running for 300 iterations. Right, and you also see up here with the summary of the parameters, because we actually call model summary now here. That's why, right? But you notice something interesting, like this one actually printed out after the summary. What does that mean? It means that it hold off from printing thing, or start printing after this was executed. So that's, you see that how the asynchronous function in place. But anyway, so we see in the models here, we see the input data that I hard-coded in, and then I try to predict using this at a test input, which is number 5, right? And then the shape is 1 and 1. So, and that's why you see it print out 9 earlier, right? So let's refresh this one now that you know the structure of it. Okay. Yeah, I just want to mention the dot then here is so that when you train your model, it would make sure that it run after you've done the training, right? So you run the training, then you do the prediction. So this is sort of a part of the a promise class. I'm not going to get into that, but keep in mind that you're not going to predict until you fully train your model after 300 epoch here, right? Okay. So let's refresh the page and see what's going on here. I'm going to go to the console to see. So here we go. There you go. So we start printing out all the loss, and you see the loss keep decrease over time. And finally, it gets to a low errors, right? So for input of, I don't know, you guys see up here, but this is actually prints out 9 and 0, 2, which is correct because our input was 5. So if we learn correctly, 5 times 2 minus 1 is 9. Cool. So that is just very simple and straightforward. You now have a machine learning model running your website, making prediction. I know it's very simple prediction, but it's all the same, depending on how you're going to design your architecture. It might do a very interesting task, right? So that's a little quick demo for you. Let's go back. And then let's talk about some recent advances in TensorFlow.js that was shown in their developer summit in 2020. So now they bring out some really powerful model here. One of the models here is Face Mesh, and it's really cool. It predicts almost 500 3D landmark to infer the approximate surface geometry of a human face, and they works really fast. 15 frames per second on Pixel 3, 35 frames per second in iPhone 11. So unlike on the iPhone, there's almost no noticeable on the real-time performance at all, right? The model size quite small, only under 3 megabytes. So this is really compact, really lightweight and efficient. So you can see the demos here. It worked pretty well. The FPS are showing up here, and yeah, worked pretty well. The next thing is the hand pose model, and this hand pose model taking image from the webcam and be able to predict 21 key points from detected hand. This model is slightly larger, it's 12 megabyte, but perform just as well on the mobile device for real-time performance, right? So you can see that for yourself. Pretty cool. Just like you're playing the Connect all over again, but now it's on mobile device and it can have very precise key points for you, right? Imagine the kind of application you can do with this kind of thing, right? And then the third thing, which is very useful, which is transfer learning. And we see transfer learning back in convolutional neural net. So this mobile net is a transfer learning framework that is small, low latency, low power convolution model designed to meet the constraint of a mobile device in variety use cases. And it's also trained on the ImageNet challenge, so it's very powerful. Predict over 1,000 classes here, right? And if you plot out the number of model parameters, and then versus the top one accuracy, AlexNet is here, MobileNet is here. So you see for the similar performance, MobileNet is a lot smaller, right? You can have really high performance but increase the size of the MobileNet a bit more. So there's a variety of MobileNet for you to choose from, and it's very comparable performance to the popular models out there, right? Like the Google Net here, similar performance, slightly smaller. And then, GGG16 is really huge. All right, so we're going to use MobileNet for a demo soon. But before that, I want to show you that we actually have more model that we can use from the TensorFlow.js library. Many of them is ready to use inside the website. It's lightweight, efficient, and you can actually retrain it for your specific tasks. So very variety of tasks that you can do here and retrain the model for your tasks. All right. So next we're gonna try to do a quick demo on a rock, paper, scissors game with MobileNet. And this is written by, again, developer at the Google TensorFlow.js team. All right, so we're done with that. So let's see, looking at our second, which is the game. So this one, I'm gonna take some capture from my webcam. So I hit allow, and you can see my webcam's up here, right? So I'm gonna play the rock, paper, scissors game. And here's a simple user interface to do it. But let's see if I want to train the example for this game. I'm gonna have to take, the rock example is this. Okay, collect a bunch of example. When I click rock, it's gonna show me the rock example. Let's do 20 example. And then paper, here's my paper. And I can also train the algorithm about 20 times. So I move my hands around, trying to get a pretty good approximation of my hands and so on. And then Caesar. Caesar is a hard one. Okay, so I'm going to train my Caesars, move around to get the right approximate. Okay, I'm training more Caesar than the others. All right, and then I click train the network to do the training, right? And then after training the network, I'm going to do some prediction. So I'm going to start prediction now. Right? See Caesar. You see rock. See rock. Do you see paper? Paper, paper, paper. Caesar. Rock. Come on. Rock. Caesar. Paper. Caesar. No, it's just rock. Rock, 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 rock. So, I mean, it has some accuracy. I think we had to maybe train more on the rock. We confused the rock and the Caesar. Like paper, Caesar, rock. Some of it want to say rock. Some of this want to say Caesar. What about down here? Confused. There you go, not rock. Anyway, I thought that kind of fun to play this game. And better yet, I'm going to leave you to the code that behind to actually make this thing works, right? So let's take a look. All right. Now we look out. Well, the loss was about 0.3, so there's some errors there. And plus, you need to use a lot more training example to get better result, right? So let's take a look at the results here. All right. So the retrain HTML, which is this website right here, this is it. Most of them just build, the interface for the application, such as these button to collect training example, handle button this, and then you have some text to print out the example. Do training is the main function to train the network. And after you do predicting, then you have some stop predicting functions to initiate your prediction, right? And the start the shows here really in index.js. We're gonna look into it, but I want also to mention thing that you had to import it here. TensorFlow.js. We're gonna import some script for the webcam, so you can handle the webcam capture, and also a script for the dataset class that you use to train your method. But the most important script would be the JS index.js here, right? So let's look into that a little bit. It wasn't that long, only 100 and change. So we're gonna look into this a little bit. Declare some variable here, webcam, grab an element webcam from the document, and then initialize the data set for the training example. And then next thing you want to do is load MobileNet. So this is a transfer learning framework. So first you want to load the MobileNet, and you can use this link. The MobileNet was saved in JSON file, so you can load using this link. And then what you're gonna do is this: you're gonna take the output from certain layer in the MobileNet. In this case, I'm taking convolutional layer 13 with ReLU. So I'm gonna extract that later out, and I'm gonna return a model that take MobileNet input and take out the output of that layer output. Right. So what happened is I have a whole MobileNet, but I'm gonna just stop at certain layer. In this case, the one that before the last, and take the output of that instead of the final output. And this is what I would call some sort of activation from that layer. Right. You can call it activation. Some people call it embedding, because this is another feature representation of the input, but whatever that is, you want to use that activation or embedding to feed into your model, right? Effectively doing transfer learning, right? So next, the next asynchronous function is string, and I'm gonna just trying to do some one-hot encoding here, because remember I have 3 label, so my label need to be one-hot encoded, right? And then what here, I started a sequential model, just like we've seen before, that contains certain layers here. Third layer is a flattened layer, and this layer gonna take the output from the MobileNet. So I'm gonna build on top of that, right? And then what I do next is simply just having the dense layer with 100 neuron with ReLU, and then the output layer is with 3 neuron, because I want to have a tree class here with softmax, right? And then Atom and Optimizer, I compiled it with optimizer, and the loss in my categorical cross entropy, just like the Python counterpart in TensorFlow. And then what I do, I call fit, right? And then feeding my data set similar than before. Oh, here I only train for 10 epoch. Maybe I should train more to get better result, right? So, and then plot out the loss functions. Cool. Next thing is trying to collect the training data, which is somewhat important, right? But you still have to do it. So you collect training data by look at the element ID. Remember here, element ID. So remember when I have a handle button this. So this is the element that is contained. So in that case, I know this element ID is 0, so I can capture that. So here, that's why I just switch on the element ID. And depending on the case, I know what example that I was trying to collect and, trying to increase that number of examples. So you can see these numbers here get increase. Now, the more important part is I parse the label from the ID. I do take an image from the webcam, right? That's important. Grab an image from the webcams here. And then what I'll do next, I'll add it to my data set. And I added 2 things to my data set. Number 1 is a label. Number 2 is not the raw image. Instead, I grab the prediction of the image from the mobile net. This would actually give me the activation of the embeddings of the mobile net that I specify up here, right? Remember, I want to take the output of some layers and then use that for my network. So that is essentially, I capture that as part of my training data, right? Cool. Next, I'll do prediction. And the prediction first is, you have to capture the image from the webcam. Remember, all of these things is supposed to be asynchronous because I don't want to block up my user interface and so on, right? So the predicted class here, I'm going to grab the image from the webcam, get it through the mobile net prediction, and then from the prediction, I take that, what called activation here, and feed an input into my model, and then I do the prediction, right? So final result, I get the prediction, doing an argmax on this, and then I get label 0, 1, 2, 3. 0, 1, 2, got 3 classes. And depending on what class that is, I would send the prediction text, which is these things right here, updated it, whether C rock, paper, or scissors, right? And then you update it using this prediction elements with the prediction task. Now there is some housekeeping sort of things. The tidy function here, trying to make sure, think about it, it's like a garbage collector after you're done with it. JavaScript trying to tidy things up, clean things up, frees up your memory for your mobile application. And this also depose here, trying to get rid of it after you're done with it. And also you are feeding the next frames in so that it would have a smoother experience. So this one for that purpose. And that's about it. Oh, another thing is the initialization. Initially, as the page load, a page load, you run init. So you want to set up the webcam, you load the mobile net, and you trying to do this function, basically trying to warm up the operation, right? So initiate all of these operation like prediction from the webcam for the mobile net, so on. So make sure everything is in place. And that's that. That is essentially how you can integrate mobile net using transfer learning to do rock, paper, scissors game. Why don't you try this for yourself? I'm going to provide a link to the code. And then hopefully you will build a better model than I do here. My model obviously is still confused a bit about the rock and the scissors, right? So let's go back to our presentation. Close the tab. Okay. So in summary, the browser-based model provides a lot of benefit for the user and also the developers. And TensorFlow.js provide an easy way to develop and deploy directly on the browser. And if you know TensorFlow Python, like we always do, TensorFlow.js somewhat similar to that, with a few chain to accommodate the JavaScript syntax. TensorFlow.js have several free trained machine learning model that you can use, just like the mobile net that we just demo. And there's a lot more about TensorFlow.js. So I encourage you to go to tensorflow.org/js to learn more. And have fun. Go try it on the browser. Experiment. That's the best way to learn. And I will see you in the next video.